Welcome to this video on electrical HVAC. We'll cover fundamental systems like cooling, heating, and ventilation, along with controls, energy management, and commissioning. We'll reference key standards, including ASHRAE, CIBSE, and LEED. Our table of contents provides a roadmap for the video, starting with the fundamentals and moving through cooling, heating, ventilation, ductwork design, electrical requirements, and controls. We'll also cover energy efficiency, standards, commissioning, maintenance, and real-world applications. HVAC, or heating, ventilation, and air conditioning, is the technology for indoor environmental comfort. It manages temperature, humidity, airflow, and air quality. Key metrics show that HVAC accounts for 40 to 60% of a building's energy consumption, with comfortable zones typically between 20 and 26 degrees Celsius and 40 to 60% relative humidity. HVAC systems can be classified into several types. The central plant, shown in the schematic, is best for larger spaces, providing high efficiency and centralized maintenance. Split or multi-split systems use DX technology for residential or small commercial applications. VRF systems offer variable refrigerant flow and can provide simultaneous heating and cooling. Other systems include chilled beams for high-ceiling offices and packaged units for easy installation, typically on rooftops. We explore various cooling systems. Centrifugal and screw chillers are used for large and medium commercial applications, offering high COP values. VRF systems provide flexibility with high IPLV. Evaporative cooling is effective in dry climates, offering high COP, but using water. Finally, free cooling leverages dry cooler or plate heat exchangers when the outside air temperature is low to save energy. For heating, we consider gas condensing boilers for high efficiency, best with lower return temperatures. Air source heat pumps are suitable for retrofits in all climates, while ground source heat pumps offer better COP, but require available ground space. District heating utilizes medium to high temperature networks. For localized heating, electric underfloor systems provide low maintenance and spot heating options. Indoor air quality, or IAQ, is critical. Limits are set for pollutants like CO2, CO, and particulates according to standards like ASHRAE and WHO. Ventilation systems include MVHR for heat recovery, DOAS for independent outdoor air handling, and displacement ventilation for better IAQ at low velocities. Pressurization is vital for smoke control, and DCV modulates supply air based on CO2 levels to save energy. Load calculation is key in HVAC design, determining the total cooling load. Major load components include solar gain through glazing, heat from occupants, lighting and equipment, and heat transfer through the building envelope. Psychrometric charts help visualize air properties, like the comfort zone, which guides system design decisions. Ductwork is designed using methods like equal friction, targeting optimal velocities, and pressure loss in different zones. Key design notes include minimizing duct aspect ratios, controlling acoustic levels, and minimizing flexible duct length. Piping designed for chilled and hot water systems requires specific flow and return temperatures and emphasizes variable flow systems for energy savings and proper insulation. Selecting and sizing equipment is based on cooling load, efficiency, and typical rules of thumb. For instance, chiller sizing is based on total cooling load over COP. AHU sizing depends on air changes per hour. Quick rules of thumb indicate typical cooling loads for offices, hospitals, and data centers, as well as required fresh air rates. Electrical and power considerations for HVAC start with the MCC or distribution board. Variable frequency drives, or VFDs, are mandatory for pumps and fans above 7.5 kilowatts per ASHRAE 90.1, offering significant energy savings. Power factor correction is necessary to achieve a target PF of over 0.95. Safety is paramount, involving earth fault protection and gas detection in refrigerant rooms. Finally, smart metering per system is often required by Green Standard. Building management systems and intelligent controls rely on communication protocols like BACnet and Modbus for interoperability. PID control loops maintain critical temperatures and improve chiller sequencing. Fault detection and diagnostics identify anomalies, such as low chiller COP. Intelligent strategies like optimum start and demand response programs contribute to annual HVAC energy savings. HVAC efficiency strategies are integral to green building design. The COP comparison chart shows high efficiencies for chillers. Strategies include free cooling, heat recovery, chiller optimization, and the use of VFDs on all fans and pumps. Green building certifications like LEED, BREEAM, and WELL dedicate specific credits to optimizing HVAC energy and ensuring high indoor air quality. Several standards and codes govern HVAC, defining requirements for energy, indoor air quality, and safety. ASHRAE 90.1, for example, is the energy standard for buildings, while ASHRAE 62.1 covers acceptable indoor air quality. International standards like CIB-SE Guide B, EN 13779, and IEC 60335-2, and regulations like the Hvac regulation ensure compliance and safety across various jurisdictions. Commissioning and testing ensure the HVAC system operates as designed. TAB involves measuring and verifying airflow and balancing circuit flows. Performance tests are conducted on chillers and AHU coils. Phases include initial design reviews, developing a CX plan, installation verification, startup checks, functional testing, and final handover with documentation and training. This slide showcases HVAC applications across different sectors. For industrial plants, chilled water and process cooling are essential. Hospitals require 100% fresh air AHUs and precise pressure control. Data centers utilize precision cooling and redundancy. Commercial offices focus on IAQ compliance using VRF or chilled beams, along with energy metering and LEED targets. Key HVAC market drivers include the global market being around $240 billion in 2024, with a 6% growth rate to 2030. Top manufacturers like Carrier, Trane, and Daikin offer a range of products, with a market share chart illustrating their dominance. Asia-Pacific leads the market by region in terms of value. In summary, remember that HVAC is a critical energy consumer. Proper sizing and the use of VFDs are essential for efficiency. Controls like BMS, FDD, and DCV provide significant energy savings. Finally, fire and air quality are non-negotiable life safety issues, and commissioning is not optional. Thank you for watching this video.